Welcome to this lesson on the icebox method, part 1. In this video, we're going to determine when we need to use the icebox method, create and populate an icebox table, and then using those values, solve for KEQ. As we've already learned, to find the equilibrium constant, or the KEQ, we need to take the concentration of the products at equilibrium divided by the concentration of the reactants at equilibrium. But we're not always going to be given the concentrations of our products or reactants at equilibrium. Often we'll only know the concentrations initially. Well, we can still use this information to find the KEQ, or the equilibrium constant, using a process called the icebox method. So icebox is an acronym in which I stands for initial concentration, C stands for change in concentration, and E stands for equilibrium concentration. And we're going to use this method to find KEQ when we aren't given the equilibrium concentrations. Now let's look at a few steps for how to complete the icebox method. Step number 1 is to rewrite the chemical reaction and draw the icebox table. For step number 2, fill in the icebox with all the given information. For step number 3, look at your coefficients and add an X where all of your compounds or elements are, and leaving the coefficients in place. Next, in your change row, use negative to show reacted and positive to show formed. Then you're going to calculate each equilibrium concentration by using I plus C equals E. And then finally, you're going to calculate your KEQ using your equilibrium concentrations. So let's look at an example to get some practice using this icebox method. So this example says that initially 4 moles of A and 2 moles of B are placed in a 2-liter container. At equilibrium, there are 0.6 moles of C present. What is KEQ? Well, we know that this is an icebox question because I haven't been given all of the concentrations of my reactants and products at equilibrium. I've only been given the equilibrium concentration of one of my products. So I have to use the icebox method to find the equilibrium concentrations of my remaining reactants and products. So step number 1 says to rewrite the equation and draw our icebox table. Well, I already have my equation written with plenty of room, so all I have to do is write my icebox table underneath. So to draw my icebox table, I'm going to draw vertical lines in between every component of my reaction. Then I'm going to draw horizontal lines so that I have 3 rows, 1 for I, 1 for C, and 1 for E. Step 2 says to fill in the table with all given information. Well, I've been given the amount of moles of my reactants and my equilibrium moles of one of my products. Well, as we know, KEQ deals in concentration, so moles aren't what I'm looking for. I need molarity for all of my reactants and products. So I have to calculate my molarity using moles over liters. So for A, I have 4 moles over 2 liters. And for B, I have 2 moles over 2 liters. And those are going to be my initial concentrations. For C, I have 0.6 moles, also over 2 liters, and that is going to be my equilibrium concentration. Make sure you're paying attention and putting your concentrations in their correct place in the box. Your initial concentrations go into your initial row, and your equilibrium concentrations should go into your equilibrium row. There's one final piece of information that I know about this reaction that I can add into my icebox, and that's my initial concentrations of my products. If I'm starting with my concentrations of my reactants and they haven't told me anything about my initial concentrations of my products, I can just assume that they are 0 and that this reaction is going to proceed in the forward direction first. Step 3 says to add an X everywhere there's a compound or an element and leave the coefficients in place. So my A is going to become X, my B is going to become X, my C and D are both going to become X. But for my b and d, I'm going to bring those coefficients up. So my 2b is actually 2x, and my 2d is actually 2x. Next, I'm going to use negative and positive to show reacted or formed. So my reactants are going to react. I'm going to subtract amounts from them. So I'm going to put negatives in the change row for my reactants. And my products are going to be formed, or I'm going to add to my products. So I'm going to put pluses in the change row for my products. Next, and this part isn't written in your steps, so you may want to add it, you're going to take those x's and those coefficients, so your x and your 2x, and you're going to bring them down into your change row for each of your reactants and products. So now we want to try to solve for x by using our equation I plus C equals E, and that's going to help us fill in our equilibrium concentrations. Well, as we can see in my C column, I have a full algebra equation. I have 0 plus x equals 0.3m. So I can very easily solve for x because I know x has to be 0.3 molar if 0 plus x equals 0.3m. Now that I've solved for x, I can put in a 0.3 molar everywhere else there is an x, and I can also solve for my 2x, which is going to be 0.6 molar. So now I have values for my entire C, or change in concentration, row. And now that our table is almost full, it becomes really easy to fill in our equilibrium concentration row, again by using our formula I plus C equals E. So for my A, it's going to be 2 minus 0.3, because again, A is a reactant, so I'm going to be subtracting concentration from my reactants in order to form products. So 2 minus 0.3 is going to equal 1.7 molar. For my B reactant, 1 minus 0.6 is going to be 0.4 molar. I've already solved for the equilibrium concentration, or actually I was given the equilibrium concentration for C, and so then I can solve for my equilibrium concentration for D. 0 plus 0.6 is going to be 0.6 molar. So finally, after all that work, we have our equilibrium concentrations. So we can finally solve for our KEQ by plugging our concentration of our products at equilibrium divided by the concentration of our reactants at equilibrium. Just remember that when you're calculating your KEQ, you're going to be using the equilibrium concentrations from your equilibrium row, and don't forget to turn those coefficients into exponents for your calculations. And that concludes the Icebox Method Part 1. Check out the Part 2 video for the next installment of using the Icebox Method, and bring any notes or questions you have with you to class.